Okay, I think we'll get started here. Thanks everyone for joining today to get an introduction to our new Horner Solutions Group Overall Equipment Effectiveness, the OEE product. And got a few people joining us today. We've got Marcy on the line with us. How's it going today, Marcy?
It's great, Tom. How are you?
Great. Marcy's, thanks for getting this all coordinated. She's our marketing gal that helps out getting everything going and make sure that we all do it right. So she's very important to us all. We also have Casey Gardner with us today. Casey, how's it going over there in Indianapolis?
Hey, not too bad. How's it going, Tom?
Good, good. So Casey's going to handle our question and answer part at the end. And then we also have Nate Beachy with us. And Nate is our Solutions Group programming guru. So Nate, how's it going today?
Not bad. Good morning and afternoon, everybody.
And so Nate's joining us today in case some high technical questions come up that the rest of us don't have answers to. He's the guy that might have an answer. We also have Chuck Ridgway that's in the background. He's traveling, so he's in and out, whether he's able to hear or not hear. So he's just going to be kind of listening today. As we get started here today, we're really here to talk about a new product from us called the OEE, or the Overall Equipment Effectiveness product. And this is a new division or group within the Horner APG group for doing pre-programmed, pre-canned solution products. And so we'll have another follow-up session talking about this group down the road, but this is going to be our first product that we roll out of that department. Marcy, can you can help, or Casey help explain to people how to post questions?
Sure. The Q&A section, that's right there on the top right of your screen. You can just post any questions you have there, and we will answer them at the end.
And then we also have a shared folder out there.
We have in the handout section, which is also one of the tabs at the top. If you click on that, it will show you the OEE sales sheet that we have, and you can download that if you want.
Outstanding. Thank you, Marcy. Overall equipment effectiveness. This is not a new technology or new concept. It's been out there for a number of years and gets thrown into the IIoT thing and lean manufacturing and on and all kinds of other three-letter acronyms and more. And it's some of the larger corporations have jumped on board and done this, and some of the smaller companies, mid-sized companies, have not yet. And so what it really is all about is keeping track of how a process or a work cell is producing or working. And so in the end of the discussion, really what it boils down to is it keeps track of uptime, downtime, good parts, bad parts, and when you're down, why are you down? So we'll go through some of those details and what that brings to the game. And out there in the industry, what you see out on the floors are a lot of red light, yellow light, green light. And we'll cover quite a bit of that as we go through today as well. The first question is OEE right for you as a customer? And the real point is, are you tracking production data? And are you tracking it with spreadsheets, with somebody manually walking around with a clipboard, a write-on board, that type of thing? So somebody's entering some information that's important from a production standpoint. The second part is it a manually or automated work cell? Is somebody working on a desk making something, or is there actually an automated PLC controlling something that's being made? And so the answer on both of those, manual and automated, is we do handle both of them with our OEE product. And then, is this information visible to managers? And I put the solo cups on here because I saw this once out at a customer site and I thought it was great. This is a very basic, I guess the term I'll use is a redneck way of doing red light, yellow light, green light. Hang your solo cup up on a pole and you can tell where they're at. But it was a purely manual process for the operator to decide which cup he needed to put up there. So, but same concept. The accuracy of this information, how accurate is it? So when somebody's going to try to make decisions on a plant on how to get performance better, if they don't have good data in, they can't make good data decisions out for changes. So the whole concept behind the OEE product is to get the good solid data in, which lets better analysis of that data. And in the end, the result of this is you got to make decisions, and we want to make it so that the choices make a better process and improve the performance. That's the whole intent of doing the OEE product. What we're doing with our products, all of the other players out there in the automation world and the PLC world are touting that they do OEE. And in reality, what they're telling you is that you can write your own OEE with our product. And so, yep, all the hooks are in every PLC to be able to do this. What we're doing a little bit different is we're writing all the code and doing all the programming behind the scenes and done, so that nobody has to write any code to do this. You plug it in, you set it up, and you start collecting your data. And so what we're showing here on this first screen here is we have the box with the OEE panel in it and the operator screens, and it has a 4 stack light instead of 3 stack light. Again, something a little different for us. And then in the center, you'll see a large 72-inch screen or whatever somebody decides to do to show a plant-wide process of what's going on at every work cell in the plant. And so we have the ability to kind of cover both ends of that. And again, the key to us is that we're providing this as a pre-programmed solution that you set up in a matter of minutes, and you can start collecting your data. And again, we're doing uptime, downtime, good parts, bad parts, and when you're down, why are you down? The blue light is a little bit of lean manufacturing process that we've added, and that is a operator call for assistance. And we'll get into that in some detail as well. Why do we need to do OEE? And it really comes down to the big 6 losses. And this is a term that's used out there for anybody that looks at OEE and evaluates what OEE is all about. And in the traditional, it's about equipment failures, the setting up and adjustments that are made on a machine, minor stoppages and idle that are taking place. Maybe your work cell has a reduced speed that's playing in. And then there comes the quality side of it, which gets into the defects and or material is not available to make the right product. It's not the right thing being made. And so the idea behind OEE is to look at that availability, performance, and loss, and those give you a total OEE calculation. And we'll look at that right here on this slide. So availability is looking at how often is the work cell available to be making product. Whether or not it's making it or not is not important. It is the work cell available? The only way it's not available is if something or someone has determined that that work cell is down and not available. Sometimes those are planned stops, adjustments, maintenance, other things that could be scheduled in, but sometimes they're a equipment failure or something else that's caused the availability to go away. The second parameter that we look at in OEE is performance, and this is production of whatever they're making, a part or a whatever it is they're making at that work cell. And so on the performance side of it, we look at total parts made, and we have an ideal cycle and part count that should be being produced within a time slot. And so that performance number needs to match what we call as an ideal trigger time for each event that completes a cycle. And then the third part of it is the quality side, which is if any scrap is generated in the production, the scrap part of it comes out and that brings the quality down. And so your performance number won't be affected so much by that because you still made the part, but the quality part is affected because it's not a quality part. And so when we look at the A, P, and Q side of this, you take a percentage goal on availability, percentage of performance, and percentage of quality, and you multiply those 3 percentages together and you get the total OEE is what comes out of all of that. And those also have goals that are set for an achievement. And so really what this is all about is information. The information that we gather tells them the all of the A, P's, and Q's and the total OEE. And then there are these top losses on your downtime. And downtime is the one that's going to affect your availability for sure. And if you don't have availability, you can't make performance. So the downtime codes are probably the key to this whole process. And so having logged downtime and knowing when you're down and why you're down is a key piece of what the OEE allows to have solid data to make the right decisions. Once you've made that decision, the results should, the action that you take to make a change or a correction in the process, you should see a result that turns into better performance and better results at the end. That's the process that OEE goes through. So where can we use OEE? Certainly it fits into just about every category that we deal with. I don't know that I would say all of these are super strong in that. So the ones that I believe that we really hit strong in is in the manufacturing sector. Anybody that's doing any manufacturing and packaging and producing parts, that type of deal, it certainly fits there. Food and beverage industry, maybe not so much on the process side of it, but on the packaging side of it for sure, plays a big role. and then also on the packaging side of the medical manufacturing sector. And so those are all very strong target markets for this product. So what do we do? What are we doing with this? How are we making this? So again, remember we started out with somebody writing data down on clipboards, on write-on boards, and so on. Then that has to get entered or keyboarded in for somebody to be able to do reports with. What we're doing on our side of it is we're generating these logs in our controller, and that data is logged on our micro SD cards. It's logged in a comma-separated variable file, which is easily exported out in an FTP file and an email transfer at the end of the shift, and other ways to get the data out. And once you have that data, you can go into any Excel spreadsheet or bring it into a database and do your analysis of that data, create your own reports and or dashboards for multi-plant type applications. And again, the idea behind this is to have this information for management to look at and analyze and make the right decisions to improve performance at that area. That's the main goal of this, is to achieve better production, better performance. So the question is, why do we need to worry about this so much? And it comes up to all of us are now competing in a global economy. And how do we compete in global economies? Well, we're going to have to do this by being better at what we do. That's what this is all about, is trying to get better. When we look at it, the shift operator, he has this work cell at his station, at his availability. And he's got a visual screen that shows him a lot of information on there, such as the goals that are set, the goals that he's achieving at the time, his total part counts, his total scrap counts. And then we've given some empowerment into the operator on this product. So initially, when you look at it, some people can look at this and say, well, this is Big Brother watching over me as an operator. And in reality, it's not. What we're trying to do is we're trying to empower that operator to give him the power to say, hey, if I'm not going to hit my quotas and goals, I want to be able to tell people why. So one of the things that they can do as an operator is they can go in and select the downtime button. And when they select the downtime button, it pops up another screen and walks them through selecting why are you down. There are 20 different parameters that they can go in and configure whatever names they want to make them. I think we've defaulted 12 of them in on our package. And so they can go in and either change, modify, add, delete, whatever they want to do. And so therefore now you're logging downtime to those reason codes. And so the operator is not going to be the one getting blamed for missing quota. You're going to look at why weren't we running? Why weren't we able to hit them? And so that's an empowerment feature for them. And so the real point is they have a goal that's achieved for this part or shift, and then visibility to say, are we on target? And the red light, yellow light, green light is all about that target. So if you're seeing a green light as a manager or a zone area manager or production superintendent, whatever, the green light tells you you are on goal to achieve your target for that shift or for that batch of parts. If it goes to yellow light, that means you've dropped below the goal, but it's certainly attainable to get them back to goal. And if it drops to the red light, that means you are at a point where you may not be able to catch back up with your goal, but management would certainly be of interest to find out why is this work cell not able to produce to meet the objective. That's the visualization at the individual work cell area. And so, as I mentioned earlier, we have the ability to project all the work cells into one plant-wide information as well. That brings you to the second piece of it, which is managers, plant managers. They care about that plant-wide visualization. This is all being produced out of our data concentrator piece, which will come up here in a couple of seconds. Data concentrator is publishing this out as a web page, or our WebMI product. So as a WebMI product, we can project that out to a large screen monitor, or some managers can visualize it at their desk. Maybe there's a manager that's off-site that has the ability to see it on his phone and so forth. So it's a very quick snapshot to come in and take a look at what's happening at each work cell. So on this particular slide and screen, you can see the red, yellow, greens are all lit. We don't have any blues lit on this one, but we'll talk about that one in a second. The other thing that's plant managers and weekly information is the reports. So each one of these data log reports gets sent out at the end of shift. And in a multi-shift application, they're getting sent out at the end of each shift. So you pre-program in where these emails get sent to with these data log files attached. Once that data file is available to managers and IT guys, they can take that information and generate a dashboard. Some of this goes to cloud-based dashboards, and some of it may be just within the plant type dashboards. And it's all up to the IT department today to determine how they're going to show that visualization. So this is basically going to look at all of the parameters on the A, the P, the Q, and the total OEE. And then it shows actual production information and quantities of parts made, as well as where they produce throughout the shift. That's what these type of dashboards are good. And usually these are for multi-plant applications or multi-zone applications where they want to see different zones that have a lot of work cells in each zone. So at an enterprise level, this is going to give them the visibility to look at two plants that may be able to produce the same thing. And I've got one plant that's overproducing and one plant that doesn't have the bandwidth to put out. Maybe you figure out how to balance those out. So what comes inside the OEE kit? It's all based on our EXLW product, which is our 6-inch widescreen format. It's in the 6-inch housing, but it's actually a 7-inch display. And it has the operator's manual already pre-programmed. And this is the home screen that comes up when you first power it up. It gives you the ability to log in and log out. It gives you the ability to pick which work cell operator screen you want to see. There's trending that shows you the trending on each one of the parameters, the availability, the performance, the quality, and the total OEE. There's another screen that they can go in and see the accumulation of downtime for each downtime code, so they can see what's been accumulated throughout that shift. And then there's also a configuration screen, which is the big setup screen to set everything up. So on this home screen, they also have the ability to see what shifts have been set up and configured to be used, and what the real-time A, P, and Q and total OEE numbers are, as well as the goals that are set for them. We also have some diagnostic lights on here to show the status of the inputs and outputs on there. And so typically the outputs are going to drive your red, yellow, green, and blue lights. And then we also have one that sends an output to the upstream device that might be connected in front of it from a processor or machine standpoint. And that device brings that in as an input from the upcoming device or cell. Inside the box, it does come mounted in an enclosure. We do make these in two versions. We make it in a non-UL polycarbonate box, and we make it in a UL 508 metal enclosure. And so this is kind of what the inside looks like for a UL metal enclosure one. It does come with the tower light, 4 colors on it that are all wired in and pre-wired, pre-programmed. Has a power supply, a disconnect switch, and then some terminal blocks in there. These are the 3 screen choices that the operator has to look at. And so the one on the bottom down there is going to be the detailed screen, and that's going to show them the most information that's available to them for targets, actual goals. It shows them the average cycle time, the last cycle time, and the best cycle time, total parts made, and the good parts versus scrap parts. All 3 of these have the ability to select uptime and downtime. So that whenever an operator needs to say, I can't produce parts, they click on that down button, and that's what's going to go in and trigger a screen that says, why are you not running? Why are you down? The add cycle button, this is a button if it's a manual work cell where the operator would touch the button. That can also be set up to be a sensor from an automated work cell to do that as well. And the scrap button is the same. It's either going to be a touch button or a sensor coming in to trigger a scrap. All of these have the ability to select the change part screen. The change part says that I've completed my batch of parts. I want to select a different part number because I'm going to make something different. And there may be some change over time to change tooling out and such to make that type of a change. This is what the tower light looks like. So it is a stainless steel housing with 4 colors on it, and they are very bright from quite a visible distance. And that is really what it's intended for, is for managers to be able to look across the floor and look for a lot of green lights. That's what they want to see. And then the blue light, again, is what we've put in for the call function. We also have added 2 ports to the outside of the enclosure, one of them for the USB connector that we'll use for doing data transfer of files. And the other one is an Ethernet port that we can use to connect up and push data to the data concentrator, as well as do FTP file transfers and a few other email option type things. As I mentioned, the WebMI product is something that's available on the data concentrator, and that's what we use to push the screen information out to the clouds or to a web browser. So this is what the data concentrator looks like. And it looks pretty much, it's the same enclosure without a tower light on top of it. Each one of the data concentrators can handle up to 32 work cells that are individual OEE workstations. And they all connect up via an Ethernet connection. Modbus TCP is the method we use to do that. They all have a WebMI device on them to be able to publish that work plant information. And then we also have a future MQTT license that's going to be available. It's on them already. We haven't done that part of the development of the system yet, but that would be for pushing data up to clouds for people to do multi-plant visualization on dashboards and such. Somebody already has that capability in their IT department, they can take advantage of that in there today and do those. So this is kind of what the system would look like, where we have multiple plants connected up via Ethernet. Again, up to 32 of them can go back to the data concentrator and give us that visualization of the entire plant. So what do you have to do to make that work? You have to set an IP address in each side of each one of the individual work cells. They physically have to get connected on a network. And then on the data concentrator side, you have to match the IP address to the device that you're trying to connect to on the other end. So that's really the only part that you have to set up on this. This is another configuration drawing that kind of shows the same type of thing, but in a little bit more of a big picture format. And so we're showing the dashboard up on top. We're showing the plant-wide and-on or large display type application. And then the WebMI piece could be to a mobile device, a tablet, a laptop, or whatever you want to push that out to. So those are all available there. On the data logging side of it, we are data logging all of the OEE information. We are also data logging the call functions. And so all of that information is there. We're also downloading the downtime codes to that. And then that file information is available as an email at the end of the shift, as well as the emails can be for the call functions as well. So how do we do the web publishing part of it? It's pretty simple. That's all built into the data concentrator. All you need to do is make it connected to the internet. And then there's a username and a password for the website access. And that's pretty much it. You set it up on the data concentrator end of it. Then on the remote device, you need to know the IP address of where you're trying to connect to and the username and password. So the best part about this, we started out the presentation talking about this, in that this is a pre-written program. You don't have to write any code. There's no ladder logic. There's nothing you need to do to make this run. You plug it in, go through a couple of setup screens, and get everything set up around your parameters of your process. Start collecting data. And once you've got that data, you've got it in, you can push that information out to whoever needs to see it and let them make their analysis and decisions based on that real-time data or that accurate data. The light tower, again, is there as ability, a visualization process for managers or anybody else on the plant floor to see those type of functions. We did add a feature into this because some of the setup parameters can get a little lengthy to do them through the screen. So we have an Excel utility program. And so what this lets us do is it lets us go in and do a part configuration, a shift configuration, a downtime code configuration, a system configuration, login, and email configuration. And so this gives you a little bit of a snapshot here on the login side of it. I believe there's 20 parameters that are in there that you can go in and say, here's the login identification and password for those 20 potential logins. That's at a work cell login. And this then is the parts configuration. These can all be set up through the front screen on this one, but the note is that if you have a process that makes a lot of different parts in one work cell, you may not want to go through the touchscreen to enter in 1,000 different parts, let's say. So this would let you do it in an Excel spreadsheet and create those part file tables and then bring that across on the micro SD card to put back into the system so they can select from them. And then this one shows the shift configuration. So there's two modes to set this up. One is batch mode, the other is shift mode. In shift mode, you may have different parts that are made throughout the shift. So that gives you the ability to switch it on the fly and without an operator having to go in and change anything. So that's a little bit more of a detailed setup that we don't allow the shift configuration to be done through the screen. So that has to be done through this utility, where the batch mode can be set up through the screen quite easily. We talked about MQTT as a future add-on for us, and this is really the push data to the clouds, and it gives them the ability to do large type multi-plant applications. So in the lower right, you can see a screen showing a map. You've got, in this case, 5 different plants, and you can see the status. In this case, they would be green or red or yellow, showing what the plant is doing from an OEE perspective. And then this lets you drill into the individual plant. You can take an overview of the plant, see what each work cell is doing at each cell. And again, giving you that visualization in a red, yellow, green. And then individual dashboards for each one of the individual work cells that's generally what people are doing at the MQTT push to cloud and dashboard level. Again, that's all going to be in a future version of this that's not getting released in the first go round with this. So why did Horner develop the OEE product? We've seen this out there for a number of years. A lot of people have been looking at doing production information data collection, and those are all things we do well with the OCS product line. We do data collection probably as good or better than anybody in the industry. And so we've seen a lot of push and buzz terms out there for IIoT, OEE, lean manufacturing, and those are all terms that are used out there in the manufacturing world. And again, all of the competition says, yeah, we do these, but they don't. They say, you can do them with our stuff. The tools are there. Well, that's true of anybody. And so we've decided to take that on a little bit further and say, let's try and help some of the customers out there and let's get this started. Do I think this is going to hit 100% of the customers' needs? Absolutely not. I think we're going to hit about 80% of what people need. And I think it's going to be very close to what you need to make, and sometimes a lot more than what you think you needed to get a very solid start on this process or a complete process for what you need. For the people that are outside that 80% and that other 20%, there's all these parts can be purchased separately and you can build it yourself and do what you want to it and make it yours. And so we're just trying to help as many people as we possibly can with this product. We do have a sales sheet that's available out there. So if anybody wants to get this, is available in one of the folders up there. And so you can go in and grab that. And what it does is it goes through and shows you what all the pieces are, talks about a lot what was in this presentation. And then it's got a list of the part numbers on the back of it, so you know what the available part numbers are. We do have an operations manual, and that is not available today because it's still being updated for the last go round of changes that we've just made, but it's very close. And so I believe we're up to 79 pages on that and growing as we continue through the development of this product. So it's a pretty lengthy operations manual, much larger than most of the manuals we produce for our products. So that kind of gives you a little bit of a hint about how big the program is that actually resides inside of this controller. We will have a video that's going to be available. We did have one, but again, that needs to be updated for some of the recent changes we've just added. And so we'll have a video for the sales front end part that we're just covering today. And then we'll also have a video for the configuration and setup of the OEE product. So for a customer to walk themselves through and say, well, what is this information really asking me for? Here's the part numbers that are available. And so the very top one is if somebody didn't want the enclosure, they don't want the tower light, all they want is the OCS controller, the EXLW, and they want the software program in it. And this is what the part number would be for that. And then we have the full panel, which is a non-UL polycarbonate version. That does come with the tower light and everything else that we saw in the pictures. The one below that is the UL 508 panel, so that'll be the metal enclosure version. And then the two below on the very bottom are a non-UL and a UL version of the data concentrator pieces. So in a typical plant application, one might need one data concentrator and then several of the work cells to fill out how many working applications you want to tie this to. So at this point, we've gone through in about a half hour, a little over a half hour, and done a quick update. At this point, Casey, do we have any questions that have come in yet?
I don't see any questions, but we'll give people some time to, if they have any other questions they want to formulate. We can also make a reminder that in addition to this webinar, we also do live streams every Tuesday at 2 p.m. Eastern. So feel free, again, if you like this, to be able to find out more content of any little tips and tricks that we kind of do within Seascape or around products, or again, maybe sometimes more details on some of our products, including maybe OEE in the future as well. Those are a good place that do routinely on Tuesdays at 2 as well.
Well, while we're waiting for some questions to come through, I think what I'm going to do is I'm going to jump into some of the setup screens just to give some visualization of what that kind of looks like when you go in to set one of these systems up. On the first screen here, this is the power up screen that you'll get, and there's a button down here for configuration, and that's the key one to go into to get into setting up the system. So when you click on that, the slide that was missing here is that you have to have a login process to get to this screen. So that means that an operator can't just jump in here and make these changes. It has to be somebody that knows the password to get to it. So the first part of it goes into the system configuration, and this is where you give it a name for the plant, a name for the cell, and how the login method is going to take place, as well as the data log interval. How often do you want to do the actual data log? There's a couple other things that come in here to check the mode of operation, whether it's batch mode or shift mode. And then how do you want the OEE calculation to take place? Is it a constant changing all the time or only on every time you complete a cycle? And then how do you want the tower light to be linked? So in other words, the default says look at the total OEE calculation. We've had a few people that have wanted to do only availability at a cell. They didn't care about it because that cell wasn't producing anything. They just wanted to make sure that that cell was available. So that's parameters like that. The second part is to get into the shift configuration. And so this is where you get to pick which days of the week that work cell is operational and how many shifts per day is it operational. And if you click the next button, it then goes in and asks you to set in your start time, stop time, and break times. And then you can hit the next button to go to shift 2 and shift 3 and so on. The next part is for the individual part editor configuration. This is really where the brains and guts of this system are. And so you go in and you identify a part name. You tell it how many parts are created every time you hit a cycle trigger. And then you also have a number of parts every time you hit a scrap trigger. And then there's an ideal cycle time. And this is one of the key parameters to this whole thing, which is the customer has to decide what is that value or that time it takes in the ideal world to make a cycle complete. And so they know that, that's their application. They're going to know that. And that's the one that they'll adjust accordingly as they get better or try to make the system right for them. The next parameter over here is a changeover time. So that's if you're changing out tooling to make a different part, changing out something to make a different part, there's some time it takes to make that changeover from one part to another. The next one down here on the left says this is your trigger point for a cycle trigger. By default, we're making it touchscreen, which means completely manual. The operator physically touches the screen. And if you click that down button on that, it's going to let you select between the touch button and a sensor type. And the same with the scrap. You can select between touch button and sensor type. The grace period is a period beyond the 30-second ideal cycle. So in this case, I've set it at 8 minutes. So at 8 minutes and 30 seconds, if it has not cycled, the system will shut down into a downtime mode and ask you to tell why are you not running, why are you in downtime, as opposed to the operator selecting that. And then the other parameter that gets set up in here is the batch mode. And this is a screen that lets you pick your ranges for your availability, performance, quality. And so you set the red and the green, the yellow automatically sits in the middle, and all of the OEE parameters automatically get calculated. Once you've done that, you can save that part to the flash card. You can load from any parts that have been saved previously. And then once you pick the one you want, you say update this part to run in the program. And that's what makes it a running parameter from this screen. The last one is the downtime codes. So this is where you get to go in and change the words that we've put in, our verbiage that we used. So you have the ability to go in and change these at this level. So the very top one says how many downtime codes do you want? And again, our default was 12, but there are up to 20 of them that you can put in. The Ethernet configuration is where you go in and assign the IP address for this device. And this is where you need to put everything to make it connect up to the data concentrator, as well as for the IT team to know how to go get FTP file data, that type of information. And then this is the email setup if you're going to do it as part of this, as opposed to the Excel utility product. So you set the email up. This is where you go into shift 1 for raw materials. And so this is on the call function. We didn't get into a lot of detail on that. The call function lets you call for help. In this case, call for raw material help. And so there's multiple people that you can call in shift 1. And then there's a timeout process that if they don't respond or acknowledge that call, it goes to the next level up. And so you put an email address for that next level up. There's also that same type of function for the maintenance calls and also for the timeout maintenance calls. And if there was multiple shifts set up, you'd have email addresses for each shift. And then this is a supervisor call. And these are, again, all the lean manufacturing call functions. And then the timeout. This has to do with downloading the files at the end of the shift. So at the end of shift 1, who do you want the data log files to be emailed out to? And then the last one is a little bit of a system information file. This lets them get in and change time and date, but it also lets them see the application version and software version of the OEE product. There's a login process, log in, enter your password and login name and password. And then there's a log out process. that lets you go in and log out of that. And then those are the three screens that we showed earlier for the detailed, the simplified, and the basic screens. So this gets into what we were looking at earlier, but this is that call function where it's a operator call for assistance. The second screen and the basic screen. Here's your downtime code screen. So this is what it looks like for the operator to pick a downtime code when they've gone into downtime, or if the system automatically went into downtime. And then this is a screen that comes up to be able to visualize what the downtime accumulations have been for this shift. These are the call functions. So when you click on the call button, this is where they can do a call for raw material, call for maintenance, and call for supervisor. And when they pick one of those, this blue light will be flashing blue, as well the blue light on the tower will be flashing blue until somebody acknowledges it. And then they will stay blue and not flashing until somebody clears it, which is the button down to the right. And then this is the operator change part as opposed to the system setup. The system setup's where you create these parts. For the operator part, all they do is click the choose new part, and it shows them a screen to pick from. And when they enter that, it stays in the downtime mode till you click the changeover done process button on the operator screen. That's what they look like in all three of them. There's the trending screens that are available. Obviously, there'll be a trend graph on all of them. And then this is the data concentrator piece that you'd visualize and see from there. I'm going to kind of stop going through these screens at this point. Casey, did we get any questions at this point yet?
No, I think we covered a lot of the details. So
that's good. Well, at this point, I think you mentioned that we've got our Tuesday webinars that we do each week on YouTube, I believe, right?
Yep, absolutely. At 2 p.m. Eastern.
Feel free to join in, and we'll have some follow-up presentations coming on the OEE product as we get down the road here a little bit further. And so feel free to join in on those. And if you need to reach out to any of us, feel free to do that at any time. And thank you, everybody, for joining us today, and have a great day and be safe.